Okay, anything from last time that we need to go over? Anything from 10.3 or 10.4? How are the story problems? They okay or not okay? Pretty good? I think we got a good sampling of all of the different ones that are in there, so I think that should work out well with the different types. And I don't think you run across any other kinds that you would end up using with those. So today we're going to look at graphing quadratic functions, and that's getting into looking at the parabolas. And we've talked briefly about parabolas. We said back in 10.1 that when we were finding the y-intercepts in there, we were looking at where that graph ended up crossing the x-axis. So if we had that information, we were finding that our parabolas were coming down on a graph, and they were coming down and doing one of these numbers, and they were crossing at that location. So when we looked at those, that's what was happening at that first part when we were looking at graphing these things. So we kind of found that piece already, and so we can do that. So we know how to do that piece. But today, we're going to find where the parabola dips down at this point, what the width of the parabola happens to be, whether it's way down here or up top farther for us to take a look at. So to continue with that, we're going to, of course, graph parabolas and determine its vertex, its domain, its range, line of symmetry, and its zeros. And this zero piece in here is the x-intercepts. So if you're looking at the zero piece, it's the x-intercepts that we're going to find. And we don't do the applied problems in this part, so we're going to cross that piece off. So the vertical line test is needed because we need to know whether we have a function or whether we don't. So in this case, they may give you a graph, and if the graph is a parabola, we could say that if we look at the vertical line test, the vertical line means we're going to drop stuff down this way. And if it only crosses in one point, we have what's called the function. And so we're going to check that part out, and we're going to see what happens with that vertical line test in there. And so if it's a function, we're great and we're good to go. And so we know that it is. If it's not a function, it might be a sideways parabola. And as soon as I drop a vertical line, what happens is it crosses in 2 points. So if it crosses in 2 points, it is not a function. So we get those little pieces in there so that we find out whether we've got functions, whether we don't have functions, and what ends up taking place with those. So that's the kind of thing we're going to look at with these as well when we go through and take a look at what your functions happen to be. So our regular general quadratic function, we've been working with this since the beginning of chapter 10, and that is in the standard form of ax squared plus bx plus c, and we have what's called the quadratic function, and we all know that. That was just kind of a review, and of course a cannot be equal to 0 because as soon as it equals 0, we no longer have that piece. This kind of got out of order. I'll have to come back to that one. And put it in more at the tail end of things because it won't make sense if I put it in there right at that point. So what we have with our parabolas is that we start to change our equation. And our equation comes out looking like this instead, where in each of these, of course, we're going to replace the h, the k, or the h, or the a, the h, and the k with different values and different numerical values, so we will end up knowing some more about what this parabola is doing. And so we're going to start out and we're going to identify what each one of these letters will do for us when we're graphing a parabola and go through and find out what effects that happens to have on the parabola. So the first one we got to look at is A. So this A that is out here, it's going to tell. Is that pen? That pen's not dark enough. I gotta get something different in there. That's kind of right and kind of light. And so it's not showing up all that great. Oh, I guess we'll go to one of these guys. This will show up better. It's going to tell us, it's going to tell the width of the parabola and the direction. Okay, so it's going to tell the width and it's going to tell the direction of where that parabola happens to be. So let's stick a number in there. So if a were 2x squared, and if we want to take a look at that, let's get our calculators, and so that we can end up going to our y equals and clear out whatever's in there, and then we can take a look at this thing so that you can see what's going to take place with it. So I'm going to put a 2, an x, and I'm going to square it. And now if I hit graph, it's going to show me a parabola that comes in and looks like so. Okay, so if I have that one on my graph, the 2 is kind of a, it's a larger number, of course, and my graph ends up looking like so. If I go back to my y equals and go down to y2, and I put in just plain x squared, and what that means is that there's a 1 in front of it, and I hit graph, that was my first parabola. And if there's a 1, I get just a general run-of-the-mill parabola. So if you look back at that 2, what it's did is it's made the graph narrower. Okay? So then, if I go to y equals, and I go down to the third piece, and I put in a third graph, let's see what happens with this one. So if I put a decimal in front of it, so 0.5 x squared, and I hit graph, there's the first 2, and what did it do to it? Well, it made it wider, okay? So as this A piece changes in here, what happens to my graph is the smaller A is, the wider the graph, and the larger A is, the narrower the graph. So that's what's happening there. So it shows me what that graph happens to be. So if I gave you a y equals 4x squared, what would you think would happen to that graph? If we put it onto a calculator, what would happen to it? The 4 is going to make it do what? Is it going to get skinnier or wider? What do you guys think? Skinnier. So this would be a narrower graph. So we get a narrower graph with that part. Okay? So if A is small, we get a wider graph. If A is larger, we get a narrower graph. Now, when you look at these, you're going to have to compare and say, okay, what is A? What's A showing me? So that's the width of my graph. So that A is going to show me, the very first piece there is going to show me how wide that graph happens to get or how narrow it happens to get. So it focuses that graph down. So if it's a larger number, it gets wider. The 1 in here is a standard parabola. And then we work our way out from that 1. And so things get smaller or get wider as we go out from 1. And so we get our different values in there. Then A also, if A is negative, the graph inverts. So it's going to switch it. It's going to make it go upside down. So if I had y equals a negative 2x squared, what would end up happening to it if I put it on graph paper, or on my graph and my calculator? So let's do that. We'll get rid of some of these guys up here. So we're going to clear out the second one here, just so that I leave the positive 2 in there. And if I put in a negative 2x squared, whoops, I want an x in there. I don't want a 2. Oops, I guess I got to erase the whole thing. There. So if I put a negative 2x and I square it, and I'm going to go down and clear this other one out too. And if I hit graph, I have the first one, which was a positive 2, and I have the second one, which is a negative 2. So notice it flipped that graph upside down. So anytime A is negative, you're going to flip your graph. So it's going to go upside down. So this one is upside down. So it's going to go. So when you graph it, it's going to go that way. It's going to still be narrow because I looked just at the 2. The 2 is going to tell me it's a narrow graph. So then if I had another one in here of y equals a negative 1/4 x squared, which way would that graph go? And would it be narrow or would it be wide? So what do you guys think? Right side up, upside down. What's happening? Upside down. And it's going to be narrow or wide? Wide. Wide because it's a quarter. Okay. That is a fractional piece, so it's smaller. So you're getting a smaller piece in here than your other one. In Hawks, it'll ask you to compare. It might give you this piece, and they might give you another number to compare to it. And they might say, what if A were 2? Is this graph narrower or wider than that? So we would have to say it's wider when you start looking at that. So this negative out front told me that it was going to go upside down. The 1/4 told me that it was going to be wide. Okay? So we good with A's, you think? So again, if you look at these, that's what your A is going to tell you about what your graph is doing when you go through and work with those. So let's continue on and find out what another one happens to be. And in this case, we have K. Now K sits off at the tail end of this whole piece. And what K does for us, it moves the graph up and down the y-axis. So it's going to make that graph go up and down the y-axis. It's going to move it from one location to another location. So it's going to take it and it's going to move it from one spot to the next within that. So if I had y equals 1/2 x squared plus 2, what this would tell me, if I were going to put that, and let's stick it on our graphing calculator so we can see what it looks like. So I'm going to clear out everything I've got in here. And I'm going to enter that in my calculator. So 1 divided by 2, x squared plus 2. And now if I hit graph, what it has done to my parabola, we had the one that had just the 2 in front of it, or the 1/2 in front of it before. What it's done is it's taken that graph and notice it's moved it up 2 places. So it's moved it from a central location, because we were at 0, 0 before, because I didn't have a K when I had just my A. So it wasn't moving it, it was just putting it right in that set location in there. And so I've moved it up to, and so therefore that's the location that it happens to sit at. And so we know a little bit more about my parabola. So it's going to go in those locations. So now what I know about this so far is I know it's an upward graph. It has a wide shape, and it is up 2 on the y-axis. So I'm gaining some more information. So it's moved it, it's changed it, and it's gone from one spot to the next. So what happens with this one? If I had y equals a negative 2x squared minus 4. What's going to happen to that graph? And again, I can look at it and know what's basically going to look like when I get done. It's going to be upside down because of the negative. It's going to be narrow because of the 2. And it's going to be moved down on my y-axis at a negative 4. So then if I put it on my calculator, negative 2x squared minus 4, and I hit graph, and it's going to do exactly what I said it was going to do. Notice it's a narrower graph than the last one. It's moved down at 4, and it's upside down. So again, just by looking at those, I know what's happening to it. So it's upside down. It is narrow, and it is down a negative 4 on y-axis. Okay, and the last one, y equals 4/5 x squared minus 3. What would I know about this one? So if you just look at your pieces, what parts do I know? So the first part I know, is it wide or is it narrow? What do you guys think? Wide or narrow? That's kind of the opposite of what you think. You usually think bigger numbers make it wider, but littler numbers make it wider, so it's wide. Based on being a 1 in front of there. What else do we know? Right side up or upside down? Right side up. And where is it at on y? So it is down to a negative 3 on y-axis. Okay, so we've moved it down, and so we have all that. So let's just double check it just so you can see it on the calculator. If I clear that out and I put in 4 divided by 5x squared minus 3, and let's see if what we said about it proved to be true, and it is. It's wider, it's down here at a negative 3. We have intercepts in here, or where it crosses the x-axis, but I can't find those right now. We will be able to, though, as we go through this. We'll be able to figure out exactly where those two pieces happen to be. And so we can find our x-intercepts based on this. Okay, so that's what K does. So you think we're good with K? So we've got A now, we have K, and now we're going to go and we're going to pick up H. And so now we need to know what H does to our graph. So if we go through and we look at H, what's going to take place now? So let's stick one in here. Say y equals A times x minus 2 square, or we'll put an A in here of 2. We'll just stick a 2 in there. That'll make up for our A. Okay, so what do I know so far? The only thing I know with this one is it's a narrow graph, it's facing upward. That's what I know. This H that's in here, the H tells where the graph is on the x-axis. So it's going to be on the x-axis this time. So we knew what happened with K. K was the y-axis. This time H is the x-axis. So we're going to move it around on the x-axis. Now the thing about this that you always, always, always have to remember is the H is opposite of its sign in the equation. So you want to make sure that's the opposite, so that if I've got 2 here, negative 2, or subtracted 2, my H in this case is really equal to a positive 2. So it goes in the opposite direction of what you think it would. So if we put this thing on our calculator so that we can see what it looks like, 2 parenthesis x minus 2 parenthesis squared, and I hit graph. What it told me in my equation, it makes it look like it should be over here at 2, but it's not. It's over a positive 2. So it's going to shift it in that direction. So it shifts it over, and so it moves it along that x-axis piece. So it's going to move it from one side over to the other side. And so my h is going to equal a positive 2 instead of that subtracted 2 in there for those. So what we know about this graph is that it's moved across here, that it is right side up, and it is narrow. So that's all I can gain with this one, okay? And it is over at 2. This is actually a point of 2, 0 because it's moving it in that direction. So what about this one? Y equals a negative 1/2 x plus 4 squared. What do you think is going to happen with this one? And what does it look like? So if I just look at the A portion, I know it's upside down because it's negative. It is narrow or wide? What would you say? It is wide? Mm-hmm. And where is it located on the x-axis? Because all I have is h. I don't have my k part in there. So on the x-axis, this happens to be located at, whoops, negative 4, 0. Because again, it's opposite of what's inside there. So it's at a negative 4, 0. And so then if we put this one on our graph, and look at it on our graphing calculator, we're going to put in a negative 1 divided by 2, parenthesis, x plus 4, parenthesis, and put a square. And when I hit graph, I'm going to end up with an upside down parabola over a negative 4 on x. And so that's where it would end up sitting. And notice it's pretty wide. So it's a pretty wide graph that we happen to have. And one more. How about y equals 8x minus 3 squared? What do you know about this graph? So what pieces would I find about it? And again, I start on the left and work my way across of what my pieces represent. So I've got an 8. So what's happening with my graph? What way is it going? Is it upward or downward? Which do we have? What do you think? 8 is going to make it go upward or right side up. The 8 is going to make it very narrow. And the 3 over here is the x-axis is going to be at positive 3, 0. And again, we'll stick it on our calculator just so you see what it looks like. So go to y equals, clear that piece out, and we're going to put in 8, parenthesis, x minus 3, parenthesis, square it, and if I look at what my graph shows me, notice it's very, 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 very narrow. It's kind of wrapped around this whole piece here, and something happened. It's not moved over. Oh, I see what happened. Minus 3, not negative 3. Now we'll get to look like it's supposed to. So it moved it over 3, and I ended up with what my value would be. So it's moved it the opposite of what it told me here. So h is always opposite. So just always remember that h is opposite of what it tells you. So then you'll end up getting it in the right spot. Okay? So that's the pieces of H's and the pieces of A's and the pieces of K's. So we've got A is going to tell us the shape of our graph, whether it's right side up or upside down, narrow or wide. K told us where it moved on Y. So, and it's exactly what K states there. So where it moves is where it's going to be. And then H, in here is the opposite of H, and it tells me where it's on my x-axis. So all that pieces, if I get my graph in this format, I can end up knowing what those pieces happen to be. So now what we got to do is in here, we need to put it all together. So if I stick it all together, what takes place with my graph? So if I had y equals 1/2 x minus 2 squared plus 3. So now I have all of my pieces of information in here. So I've got my A, I have my H, and I have my K. So what do I know about this graph? Even before I even take a look at my calculator, I could pretty much put this graph on paper and have an idea of what it happens to look like. So the half tells me that it is right side up. Okay, so it's right side up. And it is narrow. The 3 tells me it's on the y-axis. It's over 3, or up 3, I should say. And the H in here tells about the x-axis. And so it is over a positive 2. So I got to do the opposite pieces in there. So if I looked at just this graph and I just stuck it on my paper here before I even did anything else, what it will tell me is it's going to go this way. It's going to be narrow. These two pieces that come together means I'm going to go up 3 on y. But before I put my point in place, I need to go over 2. So this point that comes up here at the very bottom, and my graph is fairly wide, so I can put that in there and I can end up with what my value is going to be. And so it's one of those floating graphs. And the reason it's floating is because, and I'll show you that in a second, that we can end up taking things and end up solving and coming up with what our x-intercepts happen to be. Both x-intercepts on this one would be imaginary numbers. They're not real numbers, and so that's why it's kind of up there floating. So if we put it on the graph, let's just see if we got out of here what we needed. And what we ended up with is 1/2 parenthesis x minus 2 parenthesis squared plus 3. And now if I hit graph, it's going to end up showing me that that's what that graph does. Okay, so that graph comes down here and that graph goes up. So now there's what the shape's going to be. So I've got my shape in there of what's taking place with this. So when I put H, the negative of H, and K together, what this forms is the vertex, or the bottom of the graph. So it's the bottom of the graph or the top of the graph if the graph is a negative A. So if A were negative in here, then my graph would be upside down and this would show me the top of my graph. The other thing that happens with parabolas is there's a line that drops down. It's a mirror image on each side of my parabola. This side of the parabola is identical to that side of the parabola. And that line that drops down there is called the line of symmetry. And the line of symmetry happens to be x equals the negative h. So whatever your h is, you're going to do the opposite of it, and that's going to give me my line of symmetry. The reason it's x equals this is because it's a vertical line, and vertical lines all have the formula of x equals wherever it happens to cross at. So we've got that piece coming together so that we get that line that drops down in the middle there. And so we have our line of symmetry. So again, that's what H is going to give us. So that H has a little extra meaning to it. So it's going to give me that line of symmetry. K and H together gives me the vertex of my graph. So let's say if we had this one, y equals a -3 times x plus 3 squared minus 4. So let's see what we can come up with out of this one. So if it's in this format, what can we get? Is there anything we can get out of it? So what does it show me? So we just start at the left and work our way across and see what we gather out of this whole graph. This -3 out in front tells me it's right side up or upside down. You guys think? Upside down. The 3 tells me, is it narrow or wide? Narrow. The line of symmetry. So the line of symmetry is the opposite of H. So X is equal to a -3. And then we need its vertex. So what does its vertex happen to be? What would my vertex be? Well, my vertex is that combination of a -h and k. So it's going to end up being a -3 and a -4. And so that's the vertex. So that's where it's at the bottom of. So we can gain all that stuff just from our A's and our A's, H's, and K's. Okay? So that's, again, the pieces. As long as it looks like this, I can pull out those pieces and get my sections out of it. So got it in that format, we're good to go. The other piece that they mention in this part too is that they talk about the, and let's go to this next one. I got another example in here. Oh, this one here. We'll go to that one. And then we'll talk about our, the range and domains with these. So what's this thing going to look like? So if I look at it, what do I know about it? Right side up, upside down. Right side up. Narrow or wide? What do you think? Narrow or wide? What would we say? It's a half. So is that small or is that a large number? Yeah, so it's wide. Yeah, so it's going to be wide. So then what do we know about its line of symmetry? Line of symmetry is x equals 2. So from H, that's H, so I can end up taking that and getting 2 in there. And then its vertex. What's its vertex going to be? So its vertex is going to be 2, 4. So we know that piece of information about it. So if I look at it on my graph, so let's put it on here and clear out what I had. So I'm going to put 1 divided by 2, parenthesis, x minus 2, parenthesis squared, plus 4. And we're going to hit graph. And it's coming up and looking like so. Okay. So the things we need to do is, let me put it over here on a piece so we'll have it in our notes here. So it's coming through. It has, we're at 2, 4. And we know it has a axis of symmetry coming through at 2. It's going up like so, and it is fairly wide. So now we need to talk about domains and ranges. And we did domains and ranges before. We did domains and ranges back when we had the radicals in chapter 9, and we looked at domains, and domains were x's, so the x-axis. So what can I pick for a parabola for my x-axis? Well, since these points go on up and as far as they possibly can go, my domains always are going to be from a negative infinity to a positive infinity, because these keep going and x keeps going, and you would find if you're walking along x, you would continually find something that's related to x. Now my range is a little different, because my range is the y-axis. So if I go down here, I don't see anything, and I only hit something when I get right there. So I'm only hitting a value at that point. So if I hit that value at that point right there, what does that mean for me? Well, what point's there? What value did I find to be at that location? Well, I found that K up here tells me where that location is at. So in my ranges, I'm going to go from a bracket of K to infinity in this case. So in my case, since you have parentheses on the end, a bracket 4 to infinity will be my range for this problem, because it's showing me that that's where it's starting at. Okay, so it's starting here and it's going up indefinitely. So whatever K happens to be is what it's going to be. Now ranges, if your parabola goes upside down like so, and you're up here at 4, my range will change for this one, because if it's upside down, what's going to happen there is the domain will still be from negative infinity to positive infinity, but my range is now going to go from a negative infinity to whatever K happens to be. And there'll be a bracket out here because it can be K. And so if it's an upside down one, it just changes your range. Your range is just going to go from negative infinity, because you're going to see stuff at the bottom, to what K happens to be. And so you get some differences between domains and ranges when you look at these. Okay? So does that make sense? Hopefully. Okay. So as you go across these things, you're going to find those pieces, and you're going to kick out what your values happen to be. So let's see if we can find all of this stuff. Since we've gained and added some more stuff in here, if we can find everything we need on this problem. So can we find all of our stuff? So first thing we're going to look at is, what shape is this thing going to be? Right side up or upside down? So negative out in front, it's upside down. So we know that part. Then we can find it's narrow or wide. Narrow or wide. It's a 3, so it's going to make it, you guys think, it's a 3 in there. 3 is going to make it narrow. We get narrow. And then what's going to happen with my line of symmetry? So what's my line of symmetry on this one? Line of symmetry is going to be x equals the opposite of h. So minus 4. My vertex, and that is a negative h and a k. So my vertex on this one will be negative 4 and a negative 8. Okay, so now I've got those pieces. So then I need my domain. So what would my domain be? Always all real numbers with parabolas. And the range. What's my range going to be? And you might want to stick it on your graph and see what your graph is going to end up looking like, because that will end up telling you. Of course, we know it's upside down, so we know it's going to go at the bottom of the graph. So we know that piece. But if I put it in here, clear that piece out, and I'm going to put -3, parenthesis, x plus 4, parenthesis, squared, minus 8, and I hit graph. And I just get a little dinky tiny piece of it because it's down at a -8. But that still helps me with my range, because my range, remember, is the y's, and I'm not hitting anything up here. So I know with my range, I'm going to be going from a -infinity to k. So it's a -infinity to a -8, and that would be my range. All that out of just these little pieces, so we can look at stuff. And it may ask you, and we'll take a look at your Hawks assignment, just to make sure that we got all of our bases covered in there, and that we've got that. So we'll do that after we get done going through all of these. So does that help? That makes sense? Okay. Now the piece that I had put in here that I needed to come back and put in place, and that was my one sheet that kind of got out of whack here, is maximums and minimums. Maximum is as high as the graph goes. Minimums are as low. So this is low and this is high. So if you have an upside down graph, you have a maximum. If you have a right side up graph, you have a minimum. And so this is all ends up being based on where that happens to be. So if A is less than 0, then the parabola opens upward, and H and K is the lowest point, and the y value k is called the minimum value of the function. So your minimum is always going to be connected with k, and your maximum is going to be connected with k as well. So it's a maximum if the parabola opens downward, or upside down as we've been calling it. And you have your vertex of h and k, and the highest point of that value of k is going to be called your maximum. So minimums are right side up parabolas, maximums are upside down parabolas. Okay? So it's again this vertex point that you happen to have in there. So it's that top point that happens to be in there is what you have. So now if we go back and we take a look at that last problem that we just did, and we put that in there, let's see if we can find our max. Is it going to be a max or is it going to be a minimum? So when I look at my graph, it's upside down, so it's going to be a maximum. It's a maximum, and the maximum is at a -8. So it's a maximum of a -8. So now we got it all. We got every piece that we can possibly come up with. You guys good with that, with H's and K's and A's? Think you can figure them out of which one's doing what? Now again, it's not going to ask you for all of the stuff in one problem, and we'll take a look at those in a second here. The other thing is that not always is your equation in that format. So it's not always in y equals a times x minus h squared plus k. And so I can't always pick out my pieces in there. And so sometimes they look like this. So I have no clue is what my parts happen to be. But we can force this thing to get looking like that. So if it's asking you for the zeros, and it'll say zeros, but those again are your X-intercepts that you happen to find. Usually what happens with those is we can factor something and find them. But if you look at this one, can it be factored? Can I factor that thing? Can't factor it. No. And so what I need to do with this thing is I need to find my A, which is 1, my B, which is a -4, and my C is 1. And so then I need to use my quadratic formula. That was y, or x equals, I should say, negative b plus or minus the square root of b squared minus 4ac all over 2a, and calculate out what my x-intercepts or my zeros would be. And so let's go through and do that. So let's see if we can figure out what we got here. So if -4 goes in for b, that means I put a +4, plus or minus -4 squared minus 4 times 1 times 1 all over 2 times 1. Okay, so what comes out of this? Well, I end up with 4 plus or minus 16 minus 4 is 12. So the square root of 12, I can pull out a 2, leaving a 3 all over 2. And then this whole thing reduces to the 2's, does that triple cancellation. So I get 2 plus or minus the square root of 3. So 2 plus the square root of 3 and 2 minus the square root of 3. And so that becomes my solution to this. Okay? So that becomes my intercepts. I can't look at this and say what my line of symmetry happens to be, can I? It's not there. I don't have my H, or the opposite of H, but if I take this equation up here and complete the square with it, like I'm going to complete the square, I'm not going to finish it though. So if I take x squared minus 4x plus 1 equals 0, x squared minus 4x equals a -1. Remember how we did those? And we did the piece that we move things over. We took this piece and we took x, half of 4. What's half of a -4? -2. Squared it, added it to both sides. And what did we end up with? Well, we ended up with a -1 plus 4, or 3. And instead of taking the square root of each side, which leads me to this, I move the 3 back over. So I end up with x minus 2 squared minus 3 is equal to 0, and I have it in the correct format. Okay, so I stop one step before I take the square root of each side. So we're using that step, and we're using that skill that we developed on completing the square back in, what, 10.1b was where we completed squares at, to find our pieces. So now I can go back over here, and I can find everything I need for this equation out of just that, right? You guys think? So line of symmetry is x equals 2, because I do the opposite of what this says. The vertex is going to be 2, -3. My domain, because it's a parabola, what's my domain? My domain's always, 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 always -infinity to infinity. And my range, well, my range I need to determine, is this an upward or downward sloping thing? Well, let's say upward, right? Because there's a 1, so it's a parabola going like so. And so my range is going to go from k down here in the bottom, which is a -3, to a positive infinity, because it's upward sloping. And so I can find all my pieces out of that. All right. Now, could we have just started with this whole thing right here, and completed the square and came up with my 2 zeros? Sure, because we learned that if I take the square root of both sides, I get x minus 2 is equal to the plus or minus the square root of 3. And I would have had it right there too. So I would not have maybe had to do this quadratic piece in there, because I could have just taken that piece and finished it and came up with what it was supposed to be. Questions with this one so far? We've got more of them, so we'll go through some more that we have to find all of these different pieces too that are in there. Okay. So first we found those intercepts, or the zeros. And again, that was where it crossed at. So if I put this thing on my calculator just as it is, go back to my y equals, clear out what I have, put x squared minus 4x plus 1, hit graph, and there it comes through, okay? So it gives me the idea of what stuff I've got happening here. So my zeros are right here, my vertex is down there, my line of symmetry is coming right straight down at 2, and I've got all my pieces that I happen to have in there, or the pieces that I need for that problem, okay? So let's do another one. See what happens with this guy. I gotta find all of our little sections and all of our little pieces in here. So first off, X-intercepts. So if I look at this problem, can I factor it? What do you guys think? Can it be factored? Always look for that, because if you can factor it, that helps us out to get these guys. So this one, factors of 10 that add to 7. So 2 and 5. So set each equal to 0. So we find x is a negative 2 and x is a negative 5. So we found both of our 0 values in here of negative 2 comma 0 and negative 5 comma 0. So that is our 2 values that we happen to have. So that's our intercepts. All this, I need to complete my square with this thing, or semi-complete my square. So let's go through and see if we can do that. So x squared plus 7x, kick my 10 over. Now if you go to Hawks and you go and you look at their tutoring, they don't move this over. They leave it over here, but then you got to watch and get opposite signs and different things. It really makes it, I think, more difficult than kicking it over there and then moving it back. So half of 7 is 7 halves squared. 7 halves squared is 49 fourths. 10 becomes fourths, and it becomes a negative 40 fourths. Negative 40 plus 49 is 9 fourths. Now, in not completing the square, I'm going to move this back over. So x plus 7 halves squared minus 9 fourths is equal to 0. And so now I have all of my pieces that I need to find everything else in this problem. Okay, that makes sense? So I just went through, took half of 7 is 7 halves, squared it, added it to both sides. See those rules come back. Then I turned this into improper and added it to it, and I ended up coming up with my values that I happen to have there. So what's my line of symmetry? My line of symmetry is x equals a negative 7 halves. So that's going to split my parabola. My vertex is negative 7 halves, comma, negative 9 fourths. My domain, what will my domain be? All real numbers. And finally the range. And the range, this parabola is going upward. So it's going to go from a negative 9 fourths all the way up to positive infinity. Whoops. Parenthesis on the end. Okay. What do you guys think? Maybe? Maybe. Okay. All right. We've got one more, and then that will take care of what we got to do for lesson stuff in here. So see what you can do with this one. I'll leave it up there. And you guys work on it and see what you end up coming up with for an answer. So work on it, see what happens. Don't you have any X-intercepts yet? So if you factored it, you would find those. And they need to be put in as points because you're looking at the points where they cross. So we get that piece. Then we got to find all these other pieces. I added max and min down here just so that you had those in there. So now I'm going to take x squared minus 9x equals negative 14. So I'm going to move the 14 over. Half of 9 is 9 squared, or 9 over 2. Turn 14 into fourths. Move it back over. And you've got your pieces. Wait a minute. It should be 25 up here. 27. 25 fourths. Minus symmetry, opposite of x, or opposite of h. Vertex, combination of both. Domain is all real numbers. It's kind of a given. And my range, upward. So since it's upward, I know that my range is going to be from whatever k is out to infinity. And it is a max or a min. Which one do we have? So what way would this go? Well, my graph is going upward. So it's going to be a min. And the minimum is going to be what k happens to be. So that is my minimum. Okay. Yes, no, maybe. Okay. Now, if you get here where you cannot factor this, you can take this piece and finish completing the square. So let me just show you that. So if we complete the square, we can take x minus 9/2 squared equals 25/4. Take the square roots of each side. Square root of 25 is 5. Square of 4 is 2. And we find that x is equal to 9/2 plus 5/2 or 9/2 minus 5/2. 9 plus 5 is 14. 14 divided by 2 is 7. 9, positive 9 and a negative 5 is 4. 4 divided by 2 is 2. So I still get my 7 and my 2. So if you can't factor it, just finish completing the square. But just remember, if you're getting your parabola information, take this piece right at that point, move your 25/4 or your number back over so you get your pieces in there. Okay? Questions with any of this stuff? Okay, so let's take a break, and then I will get set up here, and we'll go through a little bit of what comes up in your assignment because it's a little different. So we'll take that. Okay, let's take a look at your exercises. Notice up above it says that there's questions 1 of 6, so it's not like you have a whole gob, but look at what happens in them. They get steps 1 through 5. And so we're going to go through and do the same kind of stuff we just got done doing with these. So is this one upward or downward? What would you say? So it is upward, because we know there's no negative out in front of my A. Then we know, is it wide or narrow? So we would click wide because it's a quarter. And I better go, well, I can't go back, so I got that one right. But on that last one, because what they're doing is determine whether the graph of the equation is wider or narrower than. So you got to be careful and pay close attention to this number, and I didn't when I did that one. I just paid attention to the quarter. So 3 is narrow, 4 is wider, so you want to make sure that you pay attention to that part in there. So we ended up picking the right one. So next. The next step, graph the parabola is to find the vertex. Find the vertex of the parabola with the given equation. So my vertex is going to be opposite h, so it's 4, and a5. So we get that part in there. Then it says, and this is one point we didn't talk about, it says find a point on the graph of the parabola that has x coordinate of x equals 2. So if you do this, let me put this piece on paper over here. What that would mean is that we would go over here and replace x with 2. So 1/4, 2 minus 4 squared plus 5. So 2 minus 4 is a -2. -2 squared is 4. So 1/4 times 4 plus 5. The 4s will cancel, so I have 1 plus 5. Or when I went back to Hawks, I would type in 6. So you're looking at finding a point in there. So, let's see, where did you go? Oh, you're back there. There we go. You would end up putting 6 in this place, and it would end up plotting that point in there. Submit your answer. And then if we go to the next one asks us for 5. So 5 minus 4 is 1. 1 squared is 1. 1/4 times 1 is a quarter. So then I would have to take a quarter plus 5, or 5.25. I think it'll let you put that in there. Whoops, nope, it won't. So let's back it up here. And we need to go to a fraction. And so 5 times 4 is 20, so we want 21/5. Well, since I get an error, try again. At 21/5 again. Why it's giving me an error, I don't think I have a clue. 5 minus 4 is 1. 1 squared is 1. 1 times 1/4 is 1/4. 1/4 plus 5. 5 turns into fourths is 20. Fourths plus 1 is 21 fourths. There we go. How about if I put a 4 down there? Okay. Submit my answer. And I got it right. And so then we hop into one of these that we need to get it into that format. And so we did those. So let's take a look and see if we can get this one to work. You get it written down on paper. So we need to get in that format. So x squared minus 8x equals negative 17. X minus 4. 4 squared is 16. So x minus 4 squared plus 1 is going to be what we put into that location. So again, it's completing the square and coming up with what that would be. So parenthesis x plus 4, or x minus 4. Pardon? Oh, it didn't. Thank you. Parenthesis x minus 4 squared plus 1. Okay. And now it wants the vertex. So again, if you ever get where you don't have that written down, you can go back over here to your previous step and it will pull up what your answer previously was. And so then you can go down here, got to close it first. And so I want my vertex. So shift, it's parenthesis, 4, comma 1. And we should be good. And then, what's it asking me now? It says find the real zeros. So we would have to go through and see if we can come up with what those would be. And the real zeros, is it going to have 1? Is it going to have 0 of them? Or is it going to have 2? So if we go back over here, let me go back to my ladybug stuff. And if I go back to this step right here, that step, and if I take x minus 4 squared equals negative 1, and you take the square root of both sides, you are going to find out that x minus 4 is equal to a plus or minus the square root of a negative 1. So when I do that, and I move my 4 over, and I get an I, the square root of 1, or 4 plus or minus I, what does that tell me? And this is going back to another section. So the other section was when I had this, I had how many solutions for zeros? I had none, or 0 of them. So I would have to say I have 0 because I get an imaginary part. So you don't have to go back and use your quadratic equation for this. If you're solving it and finding out what the quadratic is, just take this step, square root each side, and you'll get there. Okay? So you don't have to go back and use your quadratic equation. And let's see what else it brings up here. It says graph the quadratic function by identifying 2 points in your parabola. Well, we have 2 points other than the vertex and zeros. So I would need to plug in 2 points. So let's go back over here to my sheet. And that's another reason I wanted to go through this, because it had some extra stuff in there that we needed to work on. So if I plug in 2 for x, what's the y going to be? So 2 squared is 4, minus 8 times 2 is 16, plus 17. So 4 minus 16 is 12, negative 12 from 17 is 5. Another way you can find points is to go and put it on your graph. So if I go on to my graphing calculator and I put in my equation in here, I'm just going to change a couple things in my one that I had in here, and graph it. I get my graph. But if I go second to my table, it's going to show me some points in there. So all you need to do is, of course, pick some points, and you would end up putting your values in there. So use your graphing calculator when you need to find those points that you're looking for. So 2 points might be 2 and 5. But make sure you pick them so they fit within your graph. And then we need to pick another pair of points. So we might pick 3 and 2. And hit submit. So you get your answers in there. And then they go through and say, write the quadratic function. So we are into our next problem, and our next problem goes through and does the exact same thing. So I think we can skip that one, and let's just see what the others pop up to be in here. This one is upward or downward, kind of like the other one we did, so I'm not going to go through it. And this one is getting it into that format, and the questions they're going to ask you are just like the other ones. So you're going to have 4 pieces in there. And finally, the last one is, again, adjusting it and coming up with your pieces. So I think we're good. Are we good? You guys think so? Hopefully. Again, take your time with these. And if you need points, again, use your graphing calculator to find those. That brings us to the end of Chapter 10. So we need to do the review, and your test is on Monday. And then for my online, the test is the following weekend. So that's where it happens to fall. So anyway, that's that part.